A common toss-up for students is whether to major in mechanical or electrical engineering. These are two of the most popular engineering majors, so I wanted to address this for anyone who's on the fence. Now, of course, there's no right answer for these two, and I'm not going to give an answer really. These majors both have huge job opportunities in lots of sectors and have high salaries. I'm just going to explain the similarities and differences in the curriculum and careers so you can make a more educated decision for yourself. Now, to start off simple, if you've taken physics in high school, think of what you enjoyed more, the circuits part or the mechanics part like projectile motion, forces, energy, momentum, etc. I know you only got a small glimpse of everything, and this won't be a deciding factor, but could at least point you in the right direction of electrical or mechanical engineering respectively. Now, when it comes to the curriculum, let's just put it simply. What interests you more? Circuits and electronics, signals, some programming, and yes, this would be your first actual program you make, and electromagnetic waves. Or are you going to enjoy analyzing complicated forces in various systems, fluid dynamics, whether it be water or air, and heat transfer and thermodynamics? As you can see, the curriculum for both these majors is very different, but there are some similarities that I will explain soon. In a previous video, I talked about why electrical engineering is a difficult major. To summarize, electrical engineering is a little more quote-unquote magical, as in when you get that antenna sending wireless signals or the circuit lighting up an LED or whatever you have, you can't physically see how it's happening. You can't see electrons moving through wires or wireless signals moving through air. You have to understand the equipment used to detect everything and the physics behind what's going on fundamentally. This isn't as true with mechanical engineering, because especially in undergrad, you'll analyze fluid moving through a pipe, or an engine, or the forces and motion on a complex system. You can often visualize these more and see them work. So now for those who are curious about how much math will I use in these two majors, they are very similar and they both use more than most other engineering disciplines. And do expect to see calculus level math. Mechanical engineers use calculus to analyze the vibrations of a system using differential equations, to analyze complex heat flow, or something just like a rotating object often involves calculus to solve for how it will rotate given some torque. Those values you see indicate basically how hard it is to rotate the object about some point, whether it be its center or end. This is called inertia, and its equation looks like this. Electrical engineers use calculus to prove how current will move through a circuit with inductors, capacitors, and resistors, not shown here. They use it when analyzing AM and FM radio signals. They use it when analyzing electromagnetic waves in general and how they are created from something like current in a wire. Again, you may have seen something like this in high school physics already, but probably without calculus unless you took AP Physics C. So if you love math, then that's good news because both of these have a lot, and you'll see way more beyond calculus A, B, and BC. And if you choose electrical and really enjoy high-level math, then I can say that RF might be the best concentration for you. RF stands for radio frequency and is essentially the wireless communications concentration of electrical engineering. Those students learn more about wireless systems, antennas, and so on, and those classes will be very math and calculus intensive. If you're not so much interested in high-level math, then I can say that not every class you take will involve calculus for either of these majors, but just be warned that it will come up and you should enjoy it somewhat before entering either of these two majors. Now, mechanical engineers do take some circuit and electronics classes, whereas electrical engineers don't take any mechanical engineering classes, so keep that in mind. Honestly, a lot of mechanical engineers don't enjoy their circuits classes because it's not what they're interested in. But as a mechanical engineer, you will take about 2 classes on circuits and electronics, which surprisingly covers around 4 electrical engineering classes. It's just condensed and simplified for the mechanical engineers. They go through it faster, but in less depth. Then this leads to the fact that mechanical engineers can concentrate in mechatronics. This is where mechanical engineering meets electrical and computer engineering. If you choose this, you will learn more about programming and circuiting so you can work on things like robotics. Instead of just being able to make something structurally, you'll have the skills to build it, circuit it, and program it to maybe detect and avoid obstacles or whatever your project would be. Knowing this, if someone came up to me and said, I like mechanical and electrical engineering the exact same, tell me what to choose, I would probably say go with mechanical engineering and concentrate in mechatronics. You'll be exposed more to both fields than you would as an electrical engineer, you'll have a great background for the job market, and maybe if you pursued a master's degree, you'd be able to make an easier decision since you have more exposure to both disciplines. Again, there's no right answer, but all things equal and I had to pick, that's what I would say. Now let's move on to careers. A question I hear often is, if I want to work on blank, should I major in electrical or mechanical engineering? And sometimes that's a valid question, but other times not so much. For example, someone says, I want to work on alternative energy. Should I pick mechanical or electrical? Well, guess what? You'll see both those majors all over companies that work on alternative energy. So let's say you want to work on wind energy. Well, which part? Do you want to work on generating and delivering large amounts of electrical power? Do you want to take classes in how high power systems work, electric motors, generators, and so on? Or do you want to analyze maybe the structure of the wind turbine, like what shape will cause more rotation from the wind, where you need to understand fluid mechanics in terms of air? Or maybe you want to help with the manufacturing of the machinery that is used. Same thing applies for solar energy. Do you want to work on the circuitry for the solar panels and distributing the electrical power that's created? Or do you want to work on designing and manufacturing the panels themselves? Or work on the lenses that track and focus the sunlight to maximize efficiency and so on? Let's say you want to work on satellites. Well, do you want to work on the satellite communication? Or the sensors on board that take measurements? Or maybe a remote sensing system that's on the satellite? That's all electrical. Or do you want to analyze the temperature changes during orbit? Or the vibrations that occur to ensure nothing is damaged? Even something down to the gimbal that turns the antenna needs mechanical engineers. When an antenna needs to track another, it uses a gimbal that often has 3 axes of rotation. You'd mount an antenna on it so it could turn to communicate with the receiver. If the receiver is in line, then everything's fine, but if during orbit they move out of line with each other, the gimbal would turn the antenna as needed. An electrical engineer could analyze the signals that tell the gimbal how much to move, and the mechanical engineer implements the gimbal to actually move as accurately and efficiently as possible. Maybe you want to work on the new electric cars that have autopilot. Electrical engineers might implement sensors and the programming that instructs the vehicle to move based on the sensor's readings. They could work on any high power circuitry and electronics that the vehicle uses, whereas mechanical engineers could work on the motors, the design and structure of the car for safety or even aerodynamics, and also the manufacturing of the car parts themselves. Go ahead and look up electric vehicle projects at colleges, and you'll see almost exclusively electrical and mechanical engineering students working on these. Maybe you want to work on prosthetic body parts for people? Well, do you want to analyze the electric signals coming from people's muscles and use that along with some programming to tell the prosthetic arm to grab something, for example? Or do you want to make sure that the prosthetic limb can supply the right amount of force to pick up that object, or can withstand a certain amount of force without breaking, and is light enough to not cause stress on the person's body? This is what biomedical engineers might be passionate about working on, but you'll see electrical and mechanical engineers all over these projects as well. Even something like working on printers needs both disciplines. Printers receive lots of signals and use many electronic components to make it work, which is where electrical engineers come in. But remember, in an inkjet printer there are moving parts that need to be extremely accurate to place the ink. Mechanical engineers are needed for that. This applies to 3D printing as well, where there needs to be extremely precise placements, especially when we are 3D printing stuff like organs now. Mechanical engineers would help design these systems. There's rockets, aircrafts, robotics, and I could go on for a while. So many things need electrical and mechanical engineers. It's actually less common to see just one discipline working on a big project. For these 2 majors, it's not so much which major is better to work in some sector, it's a matter of what you'll enjoy more. What do you have more interest in learning and understanding when it comes to the projects I've shown you? Now, of course, there are things that do involve just one major or the other, but usually on a more zoomed in scale. Like if you want to improve the efficiency of the internal combustion engine, you wouldn't go into electrical engineering. But if we zoom out to just cars in general, then again you could go into either major, at least now with electric cars becoming more popular. It's going to help to know which sector you want to go into, whether it be biomedical, aerospace, automotive, etc., but also specifically what part of the projects you would be more interested in working on. Remember, this will be your life almost every day. Make sure you are going to enjoy going through the actual process of making these designs come to life. Put yourself in the shoes of these people and think, what will I like doing more? Now, this video is focused on electrical and mechanical engineering, but just note many more engineering disciplines are needed for all the projects and careers I've talked about. So many things are multidisciplinary now. But when it comes to these two majors, which have so many positive aspects, it comes down to what you'll enjoy doing more. Remember to like and subscribe, and if you're still having trouble deciding, check us out at majorprep.com, and good luck on your search.